Is it possible to solve an equation like x squared plus 2x is equal to 255 without using trial and error? Or is that the only way to do it? Okay, let's have a look. So this equation is an example of what we call the quadratic equation, because the highest power of x is the 2, and notice here we have x first and this has no x. And if you want to use trial and error, that means you are trying to guess and check the solution here. It's not easy, right? Because when you think about a number, you have to square that and then add it with 2 times the number, and that was 255. Maybe you can think about it as like, I want to end up with a 5. Maybe you try 5 squared, that's 25 plus 2 times 5 is 10. But if you tried x is equal to 15, it actually works. 15 squared is 225, and then 2 times 15 is 30. Add them up, we do get 255. Perfect. Yes, we did get the answer, but this is not the only solution. The other answer is actually much more difficult to guess. It's negative 16. Yeah, I don't think I can guess that. Or negative 17. I don't know. So, do we have a better way to do this? Yes, let me show you. Here's the deal. Whenever we are solving a quadratic equation, if the coefficient of x squared is a 1 and the coefficient of x, if it's an even number, such as the 2 right here, then I will recommend you to use the completing the square method. It beats the quadratic formula whenever we have an even number here. Yeah. So let me write down the steps and the notes along the way for you right here for completing the square. At the end, I'll also give you the bonus part, which is the geometry of why this works. First thing first, we need to know what we want. Just like in our lives, we need to know what we want in our life as well. When we solve a quadratic equation by using a completing a square, we want to have x squared, and technically there's a 1, keep that in mind, plus some number b times x. Ideally, we want b to be even. If it's not even, it's still doable, but you just end up with fractions. We want these two terms to be on one side. That is what we have. Excellent. So we proceed to the next part, which is that we have to add the following. This is a little formula that we have to remember. We take half of the b value and then square that. Worked out this and then add the result to both sides. I call this result the magic number. So we are going to work this out and add this to both sides. Here we go. We have a 1 perfect, 2 is the b value, so take half of that and then squared. Half of 2 is 1 and then square that, we get 1. So 1 is the magic number. Right here, we have x squared plus 2x. Go ahead and add a 1 to it and make sure we do the same thing to the other side. Now, once we have done this, in fact, the left-hand side will always be factorable, and better yet, it's always going to be a perfect square. X squared plus 2x plus 1, we will get x plus 1 times x plus 1, and that's just x plus 1 squared. And I'll also show you the geometry at the end, so just wait for that. Right here, let me just finish it. This is 256. Here, when we have a perfect square, we can just take the square roots to both sides so that this and that can cancel. And don't forget to put a plus or minus. That's how we get the two solutions. So, x plus 1 is equal to this. I can subtract 1 from both sides, so that will be minus 1 here. And then I'll put down the plus or minus. Work out square root of 256. What times 12 will be 256? And they have to be the same number. The answer is 16. I got it right this time. So square root of 256 is 16. Therefore, we have to work out x is equal to negative 1 plus 16, and the other one is negative 1 minus 16. For this, you see that x is equal to positive 15, which is the answer I told you guys earlier. And for this, x is equal to negative 17. Oh, okay, so the other answer is actually negative 17. Much more difficult to guess, right? There we have it. I think this is the best way for this quadratic equation. Now, if you're still watching, here is the idea behind completing the square. What square are we really talking about? Check this out. Look at this. We have x squared plus 2x. For the x squared, we can interpret it geometrically by looking at this length being x, and then duplicate that right here, also x, and then we can draw a square. The area of the square is precisely x times x, which is x to the second power, namely x squared. Very nice, huh? Now, we have to attach the 2x to it. This means 2 times x. Does that mean I have to extend this? If I put a 2 right here and draw a rectangle, this area is 2 times x, 2x. True that, however, it's not going to help so much because we're trying to produce a square. So check this out. Instead of drawing the whole 2, I would like to cut this in half. Like so. So I actually just want to have a 1 right here. And then if I have a 1, 1 times x will give me just x. What should we do with this though? Well, take this, put it here. So I'll erase it. I don't know how to do animations, but like this. 1, and this is also x. So this area is x. Now there we have it. X times x, sorry, x plus x is 2x. We're adding the areas. Now, as you can see, this picture, it looks that we're missing a corner, right? Certainly. What's this corner? This is also a little square. How do we find this area? It's just 1 times 1. Therefore, as you can see, if we worked out 1 square, we will be able to find out how much we need in order to fill in. And the whole thing will give us a perfect square. That's why you see that this right here is this. And that's why we took half of this coefficient and then square that, because we want to fill in this little corner here. At the end, once we add this to the original, let's say plus 1 here, this becomes a perfect square all the way from here to here. The total length is x plus 1. This is also x plus 1. That's precisely x plus 1 square. Just like that.